All right, class, we're going to take a look at example 7 on page 479. This problem is very similar to some of the later questions, I think 10, 11, 12, and 13, maybe even 10 in the online assignment. So the first thing we're going to do for this problem is we're going to find the critical values. For example 7, page 479. So this is a two-tailed test. And our alpha value is 0.05. Now what you're going to notice for this chapter, 9.1 and specifically, is there is no population standard deviation. And when there is no population standard deviation, you use a t. You use inverse t to find your critical value. So that's what we're going to do here. You can go second. And the book has a formula. The formula is on page 478. You'll get a little bit of a different answer because if you use the formula, you're rounding. But obviously, since we have the technology, we might as well use it. This is how you find the critical values for this section. Okay, so you go to number 4. All right, our area, I showed you what our area was. Our area is 0.05, but it's taking up 2 different spots. Okay. So I just want to find this critical value first, right here. So it's going to be half of this value. So I'm going to take 0.5 times 0.05. That's what's going to go in my area. All right. Degrees of freedom for this section, since there's 2 sets of data, and if you look back on this problem, this is example 7. It's referencing example 4. If you look back on example 4, there's 2 sets of data. There's GDP and CO2 emissions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of each. So what we're going to do here is we're going to take our n value of 10 minus 2. Since there's 2 sets of data, you take the n minus 2. That's how you determine your degrees of freedom. Okay? And obviously that, I don't know, maybe that won't calculate. We just know that's going to be 8, right? So I'm just going to put 8. Okay, probably would have calculated, but oh well. Here we go. Hit paste. Hit enter. So this is our critical value on the left side, 2.306. That's what the critical value is right here. Okay, well then we know this one over here is positive 2.306, right? Okay, now how do we find our test statistic? Okay, so go back into our calculator. Make sure you enter the data from example 4, which I have done. 1.7 is the first, so you can pause the video now and enter the data. Example 4 on page 474. 1.7 is the first GDP value. 552.6 is the first CO2 value. Okay, we're going to see if there's a correlation, and it makes sense. How much money does a country make, and how much fossil fuel basically do they burn? Okay, so there should be a correlation between the two. As you make more money in a country, you're burning more fossil fuel. Makes sense. Okay, so what test do we use? I'm going to quit out of here, clear this off. We're going to go to Stats, Tests, and we're going to go up to Lin Reg T test. Hit enter. I've got my data in L1. I've got my data in L2. The frequency on both of those data is 1. I don't want either of them showing up twice, so I'm just going to click 1. And our HO and HA for this problem, if you look at example 7, is equal to, so then our HA will be not equal to. Go down here, hit calculate, and we get a t value of 6.272. So 6.272, this is with a TI-80, a test statistic with a TI-84, you get 6.272, which is going to be way over here somewhere. It's in our rejection region. Okay? If we do this by hand, if you use the formula, you'll get 6.289. Both of them are really close. They're both in the rejection region. Okay? The other way you can look at this is you get a p-value, extremely small, Compare that to your alpha value. We're definitely going to reject, because when P is less than or equal to alpha, you reject. So this is how you do some of the later problems in the online. And so it's just Lin Reg T test. Hope this helps.